Alright guys, today we're going to be learning about 5.4 in the textbook, which is exponential functions. Now, first we're going to learn about the natural exponential function. So what the natural exponential function is, it's the inverse of the natural log. So we can write the inverse is equal to e to the x, and y equals e to the x if and only if x equals the natural log of y. Alright, so what do we use this for? Well, we can use the natural exponential function to solve exponential equations and logarithmic equations. So, for example, let's solve something like 9 equals e to the 2x plus 1. So what you do is you take the natural log of both sides, so natural log of 9 equals, and when you take the natural log of e to the 2x plus 1, you get 2x plus 1. So x will come out to equal natural log of 9 minus 1 over 2. Alright. Now, solving logarithmic equations are pretty similar, except you just basically put both sides to the power of e, or e to the power of both sides. Alright, now, where it gets even easier, really, is when you're taking the derivative of the natural exponential function, because the derivative of the natural exponential function is simply the same thing, e to the x. And when you take the derivative of e to something other than x, we could say u, it's just going to be e to the u, times the derivative of u. Alright, let's look at some examples. Let's look at taking the derivative of e to the negative 3 over x. So what we need to do is we write e to the negative 3x times the derivative of negative 3 over x. And this will equal yeah, about that. Negative 3 times negative 1. Now this is just stuff we learned before. Times x to the negative 2 times e to the negative 3 over x. So this will be 3 e to the negative 3 over x over x squared. Boom. Okay. Next, we're just going to touch up on indefinite integrals of e to the x. So e to the indefinite integral, or the antiderivative of e to the x dx is equal to e to the x plus c. But wait, there are indefinite integrals of e to the u, right? And that will simply be e to the u plus c. Right? Yeah. Alright, so same thing. Now, let's look at some examples yet again. We will be doing the indefinite integral, or the antiderivative of e to the 2x minus 1 dx. So what we need to do is we need to set u equal to 2x minus 1. Do that u sub. Du equal to 2 dx. Dx equal to 2 du over 2. Now we rewrite this e to the u du, and then bring out the 1/2. And then from there, it's easy. It's 1/2 e to the u plus c, which is 1/2 e to the 2x minus 1 plus c. Boom, boom, boom. Alright, and there you have it, folks.